Hello everyone, welcome to the last lecture in the plotting series of lectures. We have a new custom reading for this lecture. The HTML link and the notebook link for this reading can be found as part of plotting 4 entry on the course website. I would encourage you to go through the notebook version of the reading because that gives you an opportunity to make changes and to test your changes while going through the reading. This is a really important reading, so I'll be going through part of this reading, which is about plot design during the last video for today's lecture. The part about plot design is almost at the middle of the reading. I'm quite sure that all of you are very much capable of writing code for producing a specific type of plot given the requirement for it. Of course, you can Google any missing information in order to be able to produce a specific type of plot. What is really challenging with respect to plotting is this decision-making process, which enables you to decide which specific type of plot conveys the most meaningful information about your analysis of the data set. You're going to encounter this challenge throughout the course of your data scientist life. Teaching this part of data science is really tricky, mainly because of its subjective nature. We have tried to give you a sense of the decision-making process by introducing a series of examples. Each example is going to have two different plots, both of which try to plot the exact same analysis about a particular data set. You're going to go through all of those examples and decide which one of those plots represent the analysis in a better way. I'll be going through some of these examples as part of the last video for today's lecture. Go ahead and pause the lecture video here and download the template notebook file for plotting 4 lecture. Also download fire_hydrants.csv dataset. We are going to wrap up our discussion on fire hydrants dataset analysis. Recall that fire hydrants is a real-life dataset from City of Madison. Real-life dataset often causes problems because you will have to deal with issues like cleanup of the data before being able to do some meaningful analysis with it. I'm not going to go through the import statements which are included as part of the template notebook file. I would recommend you to go back and watch the previous plotting lectures to get a sense about these import statements in case you're still having doubts about that. The last example that we went through as part of fire hydrants analysis was generation of a bar plot to represent various styles of fire hydrants in the form of counts of fire hydrants for each of those styles. Recall that we had to clean up the style columns data by converting it into uppercase letters, and then we are computing the count of fire hydrants corresponding to each unique style by using the value_counts function. The value_counts function returns a series which we capture into a variable style_counts. This particular series is going to have as index the unique style values and as values the corresponding counts for those styles. When we tried to create a bar plot with just style_counts, we encountered a bar plot which has a really long tail. Whenever you have a plot which has a long tail, you can feel assured that that's not the correct way of generating that particular plot. One of the main reasons for that is it's really difficult for you to read the bars which are part of the long tail. We switched the analysis around slightly and extracted the top 12 style counts for fire hydrants by applying slicing to style_counts series over here. We then extracted the rest of the slice and summed up all of those values for all other styles of fire hydrants, and we added that value into the top 12 series simply by saying top 12 of other equal to that value computation. Recall that you can add a new index value pair into a series just like you can add a new key value pair into a dictionary. So you can say series of index equal to value, similar to saying dictionary of key equal to value. One of the main differences between the previous version of this plot and the current version is that I've switched the bar plot around to a bar horizontal plot by calling the bar h function instead of calling the bar function. Remember to always switch around the x and y axis labels when you switch from bar to bar h plot. We now have to say x label is hydrant count. Another change which I've made is I've set the colors of the bar to be black over here. One of the most natural series of follow-up questions that you can ask based on this plot is that give me more information about the topmost style of fire hydrant, which is spacer. One example for that series of questions would be in what decade were pacers manufactured. Let's first take a peek at the style column data over here. So I'm going to say df of style dot head, and I'm also going to say df dot style of tail. Since I want to display two outputs, I'm going to use the print function call. Notice that there are missing values for the style column. We are also seeing a lot of pacer entries, which is not really surprising. The next question here is asking which column gives year information. Recall that you can use df.columns to get a list of all the column names when you have a really large data frame. The year manufactured column gives us information about the year during which each of the fire hydrants were manufactured. What we are going to do now is we are going to extract part of the fire hydrant's data frame by only mentioning style column and year manufactured column. Recall that we can do that by mentioning a list of column names inside df of square brackets. I'm going to mention style as my first column name and year manufactured as my second column name over here. And let's take a peek at this particular data frame. Looks like we are able to extract part of the data frame which just contains style column and year manufactured. What we want to be able to do next is we want to get the decade for pacers and other styles of fire hydrants. Let's split this question into two parts. Let's first deal with the second part. How do we extract part of this data frame which represents pacer data, and how do we extract part of this data frame which represents all other style of fire hydrants? Recall that we can write a simple Boolean expression like df of style equal to pacer, and this is going to return a Boolean series for us. I'm going to capture that into a variable called b, and then I'm going to apply b back to the original data frame. That's going to give us the sub data frame where you have all the row entries only for the rows where the style column is pacer, correct? I'm going to capture that data frame into a variable called pacer underscore df. What I'm interested in is just the year underscore manufactured column. So I'm going to say pacer underscore df of year manufactured to be able to extract the year manufactured column. And let me capture that into a data frame variable called pacer underscore years. And I'm going to take a peek at pacer underscore years by doing the head function call over here. Right, we have a series of year values just for pacer style of fire hydrants. Let's now deal with all other styles. I'm going to show you one more way of writing these set of pandas expressions over here. I'm going to stitch them all together into a single expression. First of all, we need to change the comparison condition to not equal to pacer in order to extract all other styles of fire hydrants, correct? Once I have that Boolean expression, I can apply that back to my original data frame by simply saying df of that Boolean expression. But I only want to extract the year manufactured column. So I'm going to say df of year manufactured of that Boolean expression. And that's going to give me all the years for other style of fire hydrants. Let me capture that into a variable called other underscore years. And I'm going to take a peek at other underscore years as well here. Looks like we are getting two different series which represents Pacer's sub data frame and the Pacer's part of the data set and the others part of the data set over here. You should be aware of both of these ways of writing these set of pandas expressions. Feel free to explore more. You have a lot of columns in this data set. Try to write your own expressions for other columns. What we are going to do next is we are going to deal with extracting decade instead of just saying year. So when you have your year as 1996, your decade is 1990, correct? If you have your year as 1987, your decade is 1980, correct? There is a very easy way in Python to extract this particular computation. First of all, let's apply pacer underscore years divided by 10. That's going to divide all the values in the series by 10. Recall that we are applying element-wise operation here. Instead of doing regular division, if I use integer division, that's going to round up these values. Instead of saying 199.6, we are going to get 199.0, correct? That's exactly what we need to be able to generate the decades, right? We can just multiply this by 10 and that will get the decades for us. So if we want to extract the century, we can integer divide by 100 and multiply by 100. That's going to get you a value of 1900 for this value and 2000 for the 2010 decade. We want decades for the purpose of this example, so I'm going to go back to the previous version. Let me capture this computed series into a variable called pacer underscore decades, and I'm going to repeat the same for, let me see, give me just a second. I'm going to repeat the same for other underscore decades over here, right? I'll have to replace pacer underscore years with other underscore years. Let's also display the top few rows of each of these series over here. The next question is asking us to count the decades for pacers and others. That's very easy once you have pacer underscore decades and other underscore decades, right? That's because you can just use the value underscore counts function, which is going to give you counts corresponding to each of those decades. And you can do the same with the other underscore decades as well. And I can say value underscore counts over here. Notice that you're getting different decades for other styles of fire hydrants and different decades for pacer style of fire hydrants. One weird thing about both of these series is that the year index value is a floating point type, correct? That's happening because of a couple of reasons. First of all, we have the original data in the year manufactured column as a floating point value. Actually, that's one of the main reasons. Since the original columns type is a float type, any computation that you make after that is always going to be a floating type. Let me introduce you to AS type function in pandas, which is going to enable you to convert a type of all the values in a given series into a different type. So you can say dot AS type of int to be able to convert all of these values into integers. Let's go ahead and try to apply as type int. I'll have to say pacer.decades.as type of int. Unfortunately, this will not work. That's because our data contains NaN values, which is not a number. Whenever you have NA values in your dataset, you'll have to deal with those before being able to call the value counts function. The value counts function cannot really count up NA values. There are two different options for you to deal with NA values. First option is to just drop all the rows that contain NA values. That's the option that we are going to go with now. But let me briefly talk about option number 2. You have a fill NA function in pandas, which enables you to fill in entries for NA text field, not text fields, any field in your data frame which has NA can be filled in with a different value by calling the fill NA function. You can explore that particular option, but for the purpose of decades over here, it's not really easy for us to fill in some value in place of NA values, right? What decade will you choose? It doesn't really make any sense for you to use fill NA for this particular context. So I'm going to go ahead and comment this line and say that this doesn't work because of NA and values in our data set. And what we are going to do now is, we are going to first of all drop the NA values by saying drop NA, and then we are going to convert the values into an integer, and finally we are going to do the value counts over here. I'm going to capture this series back into this exact same variable, and I'm going to display head of that series. What we want to do is to repeat this process for other underscore decades, correct? So I'm going to say other underscore decades instead of pacer underscore decades. And instead of displaying the head over here, I just want to display the entire series. Looks like we are getting the same series as above, but with decade column converted to an integer. What we are going to do next is, we are going to put both pacer and decade series together into a single data frame. You might run into problems with that because you don't have specific index values for both of these series here, right? What pandas is going to do in that case is, it's going to fill in NaN values for all of those row indices for the column which doesn't have the data. Since we already have two series, I'm going to create a data frame using a dictionary of series. I can do that by saying data frame of a dictionary, and my first key is going to be my column name, which is going to be pacer, and my value is going to be pacer underscore decade series. And for the second column, my column name is going to be other, and my value is going to be other underscore decade series. Let me capture this data frame into a variable called plot underscore df, and let me go ahead and display plot underscore df here. Looks like we have the data frame. We do have NaN values for pacer style of fire hydrant, where we didn't have the corresponding information in the pacer decade series. What we are going to do now is, we are going to create a bar plot for visualizing this data frame. This is the very first example where I'm going through bar plot visualization using a data frame. So now when I say plot df.plot.bar, what is going to happen is, you're going to get one bar for each of the entries in your data frame, and you're going to get two such corresponding bars, one for pacer style and one for the other style. Let's go ahead and visualize the plot over here. Notice that for every decade, you're getting two associated bars which correspond to each of those column values for pacers and others. And the bars show up on a side-by-side manner. Whenever you plot a data frame as a bar plot, you're going to get side-by-side plots for those bars which represent the column values corresponding to one particular row over here. all of the data before 1950 seems to be really less significant, right? Let's eliminate that part of the data set from our data frame. I can do that by saying I want to get rid of all the index for the decade which are lesser than or equal to 1950, right? Or I can extract the part of the data frame that comes after the index value of 1950. I'm going to have to say plot df dot index should be greater than or equal to 1950, and this is our Boolean condition itself. So we need to apply that back to plot underscore df to extract part of that particular data frame. Now that we are able to get part of the data frame which just represents the data after 1950 year, we can generate the exact same plot as before. Let's first capture the return value of this plot, which is access a plot object, into a variable, and I'm going to set x label as decades, and I'm going to set y label as hydrant count over here. I'm going to rerun the original plot. Let's copy paste this code over here so that we can apply the bar plot to this filtered data frame. And I'm going to capture the return value into variable AX. Right, the plot looks slightly better now. One other additional improvement which you can make for these multiple bar plots over here is you can stack them up one on top of other. Why does that make sense for this particular example? Let's say that I'm asking you a question of how many pacers were manufactured in 2000 decade. It makes total sense for you to stack up let me rephrase the question. How many fire hydrants were manufactured in the decade of 2000? So it makes sense for you to stack up the pacer bar over here and add the other bar on top of pacer, because that will give you a sense of total count of all the styles of hydrants manufactured in that particular decade, correct? You can do that by passing an argument to stacked parameter, which is part of the plot bar function over here. We'll have to pass the argument to the stacked parameter as true, and that's going to stack up the bar plots over here. You need to be really careful as to when you want to stack up the bar plots, because if those bars are totally unrelated in the sense of generating a cumulative value when you stack them up, then you should not stack them up. In this particular example, it makes sense for us to count up all styles of fire hydrants in a particular decade. So it makes sense for us to stack up the bar plots over here. I'll wrap up this video here. In the next video, we'll go through the next set of topics that we'll be covering as part of today's lecture.